So hello everyone, in this video we'll be discussing the LeetCode Biweekly Contest 171, and the contest was on pretty much easier side. And yeah, in this video we'll be discussing the first three problems. So the first three problems were also easy to medium only, but yeah, we'll try to wrap up these three questions very quickly because there's nothing much to explain much in these three questions. But yeah, I thought just to make a video about that. So yeah, let us start with the first problem. First problem is complete prime number. So you are given an integer num. A number num is called complete prime if every prefix and every suffix of num is prime. Return true if num is complete prime, otherwise return false. And then they have given some note, you can read that particular thing. So what they are saying is that you are given an integer num. Let's say that num is 1 2 3 9 7 8 6 2 3, so on and so forth. I think the max value was 29, so yeah, let us just remove this one number. So 3 yeah, it is correct. So this is the particular num value, let's say we have taken. So we need to check whether this particular num is complete prime or not, and in order to check whether it is complete prime or not, we need to check if every of its prefix as well as every of its suffix is prime or not. If every of its prefix and every of its suffix is prime, that means that particular number num is a complete prime, otherwise we need to return false. So that means we will check this prefix, we will check this prefix, we'll check this prefix, so on and so forth. We will check every prefix whether these are primes or not. Then we'll come to suffixes, we will check these suffix, so on and so forth. We'll check each and every suffix, and we will check whether all of its suffix are prime or not. If every suffix and every prefix is prime, that means this particular number is complete prime, and we'll return true, otherwise we'll return false. So we can just apply a simple brute force approach to this particular part. So let us see the code. So this is the function to check whether a particular number is prime or not. So basic function, no need to much explain in this particular part. First we are converting this particular num to string, because the num value is 10 raised to the power 9, so string length can be as max as 9. So first of all we are converting this particular number to string, because that will be easier for us to get the prefixes and get the suffixes as well. First we will check whether this particular number is itself a prime or not. If not, we'll be returning false. Now we are coming to check all the prefixes. So we'll take the prefix from simple substring value from 0 to I. Let's say the num value is 1 2 3 4. So from 0 to I is, let's say, here. So we'll be taking this prefix. Same for suffix, will be taking from size minus 1 till I. So we'll be starting from the end. So size minus 1 minus I. So let's say this kind of suffix we'll be getting. So we'll be getting the prefix, we'll be getting the suffix, we'll be checking whether this particular prefix, whether this particular suffix is prime or not. If it is not prime, we'll be returning false from here only. Otherwise, after checking all the prefixes and after checking all the suffixes, if we didn't return anywhere false, that means it is a complete prime, so we'll be returning true. So just a simple brute force approach would give you an accepted for this. So yeah, this was the solution for this particular question. Let us just move on to the next question. So this is the second problem that they have given. So the problem name is minimum operations to make binary palindrome. So you are given an integer array nums. For each element nums of I, you may perform the following operation any number of times, including 0. You can increase nums of I by 1, or you can decrease nums of I by 1. A number is called binary palindrome if its binary representation without leading zeros read the same from forward and backward. In the end, your task is to return an integer array nums where answer of I returns the minimum number of operations to convert nums of I to binary palindrome. So the question is saying that let's say you are given an array nums 1 2 3 4, let's say, a very basic example. So you need to convert each and every element to binary palindrome. What a binary palindrome is let's say you are this is a binary string, so this reads same from forward and same from backward, so it is a binary palindrome. So for each and every element you need to convert it into binary palindrome, and you can perform two operations. Either you can add +1 to it, or you can add -1 to it, or you can subtract -1, whatever, -1 to it. So with these operations you need to make those numbers binary palindrome with minimum number of operations required. So when this minimum kind of thing comes, that means you need to take the nearest element. So let's say we have a nums array like 67, 78, 92, 99, so on and so forth. Let's say, I don't know whether this is a binary palindrome or not. I'm just taking some random example just to explain what the core logic is. So let's say this is the current number 67. So what can be the closest binary palindromes to it? There can be something towards its right, which is a binary palindrome. There can be some number to its left, which is a binary palindrome. These left and right can be the nearest binary palindrome. So you will try 67 to make you will try 67 to convert either to this right value or to this left value, and whatever like operations needed, it's the minimum among those, either left value or the right value, will take that. So either number of operations required to convert 67 to left is, let's say, op1, and the number of operations required to convert 67 to this right value is op2. So you will take minimum of those, but you will take the nearest, either right or left, because there is no point in going forward if you need the minimum number of operations. So that means one thing is for sure, that we need to first compute all the binary palindromes. Now why I am saying that we need to make all the we need to get all the binary palindromes, because if you look at the constraints, both nums values can go up to as max 5000, and nums of I value can also go as max as 5000. So we can just find all the binary palindromes within this range 5000. So we'll find those binary palindromes, and we will just push it into a vector or array which will be containing all the binary palindromes. Then for each and every nums of I value, what we can do, we can check what is the element which is nearest to its right within this binary palindrome. We will check that. We'll calculate the number of operations required. Then we will check to its right what is the binary palindrome towards its left. We will calculate that operations as well. Let's say this is op dash and this is op. Whatever gives you the minimum operations, you will take that for that particular nums of I, and then we'll move forward. So simple intuition behind this problem is this. So yeah, let us see the directly code now. How we'll be solving this problem. So yeah, this is what the code look like. So this is the final answer that will be returning. So let me just zoom in a little bit. So yeah, so this is the final answer that will be returning. This is the palin array or the vector which will be containing all the palindrome or the binary palindromes within the range 1 to 5000. Why? Because the maximum range for the number is 5000. Then we are taking we are calling a function whether to check this particular I value is binary palindrome or not. If it is, we'll be pushing it into the palindrome vector. Now how we are checking that a particular number is a binary palindrome or not? Just we are declaring two variables L and R. We are taking R to the what is the last set bit. So we are just pointing R towards that. After getting the R, we are just running a while loop by simple checking whether that particular bit value of L and bit value of R is equal or not. If it is equal, so we'll be continuing. If it is not equal, that means for sure this can't be a binary palindrome, because if it would be, then it would be same from left and right as well. So if it is not, we'll be returning false. Otherwise we'll be moving our left and right pointer until we complete the iteration. In the end, if we didn't get any false, that means it is a binary palindrome, so we'll be returning true. So yeah, this is what this binary palindrome function is doing. This is just the basic operations to check whether this particular left bit and right bit is set or not. Simple bit operations, nothing else. So yeah, after calculating this, after getting all the binary palindromes within the range 1 to 5000, what we are doing, we are sorting. Why sorting? Because we need to, for every nums of I, we need to take its nearest right value and nearest left value possible. So that's why we are sorting this palindromes, because we'll be applying like lower bound to it. So that's why we need to sort this binary palindrome array. Then for each nums of I, we'll be doing the following operations. We'll be taking lower bound of this palindrome, the palindromes that we have taken for this particular nums of I. For this, we'll be getting the right value. For this right value, we'll be calculating the number of operations. Then we'll be calculating the left values operation. So for that, we'll be just taking one value like previous to it. So whatever the previous value was towards this IT, that would be the left value for this particular nums of I. So we'll be calculating the number of the number of operation for this nums of I towards the left value. We'll be updating our minimum, whatever is the minimum among both of these operations, and then we are just pushing that number of operations for that particular index into our answer vector. We're doing all this operation on each and every value of nums of I. After doing that, we'll be just returning the answer vector. So yeah, this was it about this second problem. So I'm just moving fast because like this is easy to understand. I don't think I need to dry run on by taking some examples. It is very easy to understand. Yeah, it is very much intuitive. I think if you need some minimum operations, you'll just take the rightmost value. You will just take the leftmost value. Whatever gives you the minimum, you'll take among that. You can't go further because you'll be obviously getting the minimum from the nearest value. You can't get a minimum from a larger side. So that's why I'm not explaining it deep by dry running and all that thing, because I think these first three problems were much more intuitive. I don't need to explain much things about that. So yeah, I hope you understand. So let us just move on to the third problem now. So this is the third problem, maximize points after choosing k tasks. So you are given two integer array, technique 1 and technique 2, each of length n, where n represents the number of tasks to complete. If the ith task is completed using technique 1, you earn technique 1 of I points. If it is completed using technique 2, you earn technique 2 of I points. You are also given an integer k representing the minimum number of the minimum number of tasks that must be completed using technique 1. That means you must complete at least k tasks using technique 1, and they do not need to be the first k task. That means you can choose those k tasks in any order. The remaining task may be completed using either technique. So this is also a good thing. That means after choosing the k tasks after using technique 1, it is not necessary the remaining tasks need to be done by technique 2. Those remaining tasks can be done by either technique 1 or technique 2. So this is also another important thing to observe, because I did a mistake here. The remaining task I just did it with technique 2 and just submitted, so it gave me wrong answer. Then I just look at this particular line, either of the technique, so then I corrected it. So this line is also important line. So yeah, in the end you just need to return the total maximum number of total points that you can earn. So I think according to the third levels of the question, this is a pretty much on the easier side, because I don't know, like in previous of in one of the contests I have solved this kind of question, and I don't think exactly, but I think it was the second question. The similar strategy was used in that particular problem as well. So I think that problem was question number 2. It was a very long ago some contest, but yeah, the similar logic was used, and this time they have given it in the problem 3. And if you actually look at the problem 2's points and problem 3 point, I think they were both 5. So I think the 2 and 3 problems difficulty is almost same, because I don't think why they would be giving 5 points to both of them. And if you look at the solution, if you have already solved, you will find it pretty much easy and similar to the second problem's difficulty. So yeah, let us discuss not about these things. Let us directly jump onto the solution, how we are going to solve this particular question. So the most important thing that we need to take care about is the technique once k tasks, and we need to take care about the maximum points that we can earn. So we need to make sure that we complete at least k tasks using technique 1, and we need to in the end have the maximum number of total points. So how we can do that? Let us understand with the help of simple intuition. Let us say we have only two points given to us in technique 1 and technique 2. In technique 1, let's say this is the array of technique 1 and this is the array of technique 2. So this one contains 1 and let's say 1 again. This technique 2 contains 1 and 100. So you need to have the k value as k value given to you is 1. So you need to use technique 1 at least one number of time. So just tell me by this simple example, which one would you rather pick, this particular technique 1 or this particular technique 1? Obviously you will be taking this particular technique 1, right? Because corresponding to this technique 2 value is 10 and corresponding to this technique 2 value is 100. So the difference is now of 99. Here the difference is of 9. So here you have the minimum loss and here you have the maximum loss. So why would you take the maximum loss? Because we need to in the end return the maximum points earned. So you need to, for this k values, you need to take those technique 1 such that your loss is as minimum as possible. So that is the most important observation in this question, and yeah, this is the main idea behind this question. So what we can do, we can just create a 3D vector kind of thing. In my case I have taken a pair values, so yeah, you can do anything like that. So what you can do, let's say you have 3 values stored. One would be the loss, one would be the technique 1's corresponding value, and the third one would be the technique 2 corresponding value. So for each and every particular technique points, we'll be calculating the loss. We'll be putting the technique 1 value and technique 2 value. For the first k value, then we will sort this because we need to have the minimum loss. So this will be sorted on the basis of loss ascending in the ascending order. So first value will be the minimum value according to the loss value. So after sorting this, we'll be getting the minimum loss values first. So for the first k values, we'll be using technique 1 because after sorting we'll be having the minimum loss. So for those first k value, we can just choose technique 1. For the remaining values from k plus 1 till the n, we can take either of the technique 1 or technique 2, whichever is the maximum. And yeah, this was the solution for this problem. So let us directly see the code now, how it is gonna work. Again, it is the simple code what just I explained. So you can take a 3D vector or anything, a 3D array or whatever. I have taken vector of pair, where this particular value will be the loss, this particular value will be the technique 1, this particular value will be technique 2. This loss value is nothing but let's say v dot first. This technique 1 value is v dot second dot first, and this technique 2 value is v dot second. So yeah, just a basic idea because we'll be using these terminologies in the further code. So first of all, we are just calculating the loss. We are pushing the technique 1 and technique value to corresponding to that. After creating this 3D vector or whatever you say, vector of pair, we are just sorting on the basis of this loss value in ascending order because we need to minimize the loss for those first k values. So we'll be just iterating over the entire vector, and we'll just check whether our currently I is less than k. That means these are the first k values that we need to choose as minimum loss possible. So we are just taking that technique 1 value corresponding to that. And what is technique 1? Second dot first. So v of I second dot first. So we are just adding that particular value to our answer. Otherwise, if we have already taken those k values, then we have the choice. Either we can choose technique 1 value or we can choose technique 2 value. But since we need to maximize our point, we'll be taking maximum of both of these values. So either we can take maximum of technique 1 or we can take technique 2. So technique of 1 is what? Vector of I dot second dot first. Technique 2 is what? Vector of I dot second dot second. So yeah, after doing this for the entire array, we'll be getting the maximum number of points. So we'll be returning that particular answer. So yeah, this was it about the LeetCode Biweekly Contest 171. So yeah, I hope you learned from this solution. Thank you for watching.